So we're continuing on with this golf ball function. Now we're going to find some more information. We're going to grab our graphing calculator and find the domain and range. So I'm going to use the y equals button on my calculator and type in -16, and then I can use just the x squared plus 60 times x and then hit graph. So I need y equals at the top left and graph at the top right to get an idea of what this parabola looks like. You might need to adjust your window to see the whole thing, but we want to determine the appropriate domain and range. So looking at this upside down parabola, it would look like the domain is all real numbers, and the range goes from -infinity to whatever my y value is for the highest point, which we already said was 56.25. So we want to determine what the relevant domain and range are. Because if you hit a golf ball yesterday, it's not still moving. So we can't say, well, the domain is from time being -infinity to time being +infinity. That's not true. The domain is starting from when we first had the ball on the ground. So time 0, the ball is on the ground until the time that it reaches the ground again. So to figure out this domain, we want to see what heights or what times correspond to a height of 0. We could already tell by our chart a couple videos ago that we were looking, like between 0 and 4 seconds approximately, that the golf ball was in the air, but we're going to factor this to figure out what time exactly the ball is in the air for. So I want to think about the biggest numbers that go in to 16 and 60. So say I want to pull out that -16t. Well, -16t times t would give me -16t squared. And then I want to do 60 divided by 16, which would be a positive 3.75. So there's 2 times where the ball hits the ground. At time 0, -16 times 0 would be 0. And also at, we got to be careful on this sign here. We'd have to multiply a negative times a negative to get a positive 60 at time 3.75. So there's my domain. The ball is hit at time 0. It's up in the air until back down at 3.75 seconds, which we knew it was sometime between 0 and 4 seconds based upon our sketch earlier. The range is the lowest the ball goes down. So looking at my graph, it looks like the graph goes down to -infinity, but in terms of the context of this problem, we're starting out at 0 feet. You can't be below the earth to start when you hit your ball. And then we already found the y value of the vertex. The highest y value that we saw was 56.25 in the last video. Every parabola has a line of symmetry or an axis of symmetry, which is a straight line that passes through its vertex. So if the vertex is located at HK, then the axis of symmetry, it's a vertical line. So if we think about any vertical line, what stays the same on a vertical line? The x value or the y value? Well, the y value goes up and down. So this is where the x value stays the same as the x value of the point. So x equals h. So our axis of symmetry, since our vertex for this one, our vertex was 1.875, 56.25. Our axis of symmetry is going to be x equals the x value of that point. X equals 1.875. So just to summarize, in general, quadratic functions have a vertex. Quadratic functions may also be given in another form, which we're going to get into. We're going to write a vertex form, which is a times x minus h plus k, where hk is the center. If we're not talking about word problems specifically, the domain is going to be all real numbers. Our domain was not all real numbers because the ball wasn't in the air from negative infinity to positive infinity. Our ball was in the air from 0 to 3.75 seconds. And then the range is usually from that vertex to infinity or negative infinity to that vertex. Ours was not negative infinity to our vertex because our lowest down the ball could be was 0, but it went 0 up to the vertex. So we're going to look at some more functions and see what we can do in more general forms outside of just this golf ball word problem.